This section is looking at surface area and volume of a sphere. Now we start off with our definition of a sphere, and it's a set of all points in space equidistant from a given point called the center. We've talked about circles before, which are just a two-dimensional version of a sphere. In a circle we have a set of points on a plane equidistant from a center. Now we're taking that center and putting it somewhere in space, and all of the collection of points the same distance away we comprise of the sphere. Now, the really important thing we're going to want here is the radius, because that radius is actually, let's draw the line in here. The radius is that measurement, is that distance that all the points are from the center. Same idea in the circle. So that radius is going to tell us how big the sphere is. Other things that we have are the chord, and that would be if I connected 2 points within the sphere, 2 points on the sphere, that would give me a chord. Same idea with the circle. And a diameter, which would go through the center of the sphere, and typically, like we saw with the circle, we'd always take that and take half of it to get the radius. So really, when we're looking at surface area and volume here, we're going to want to find the radius. Figure out what that radius is, because that tells us how big or how small the sphere is. So our formula for a surface area of a sphere is 4 pi r squared. Now if we look at that formula, the only thing we really need here is to figure out what the radius is, which makes sense. Smaller radius, smaller sphere, larger radius, larger sphere. But if you also notice, the surface area of a sphere is also 4 times the area of a circle with the same radius. So we could almost take 4 circles that would be formed by the same radius, and they'd actually overlap onto it and cover the same amount of surface area. Now let's look at 2 examples down below. I have a radius of 8 inches. So my formula is 4 pi r squared. That's 4 pi times 8 squared. 4 times 64 pi, and that gives me 256 pi inches squared. And our other one, we look at it, 18 is not the radius, it is the diameter, so our radius is actually 9, it's half of that. So our surface area would be 4 pi r squared, 4 pi times 9 squared, 4 times 81, pi, and 4 times 81 is 324. So 324 pi meters squared. So there's our surface area. Now let's look at volume. The formula for volume is a little bit different. 4/3 pi r cubed. Now still, if we look at it, we have r cubed. That radius is still the only value we need, but it's changed a little bit. Now it would be easy to remember here the difference, because we should remember that volume means that our units are cubed, and in this case it's our radius is cubed. In surface area it was radius squared, unit squared. Here it's radius cubed because it's units cubed. We also throw that 3 in there because it's 4/3 pi r cubed. Now if you can use those to help you remember to keep the formula separate, it might help you out. So now we're going to look at the same 2 spheres, but now we're going to find the volume. So that's 4/3 pi r cubed, 4/3 pi times 8 to the 3rd. And if we look at 8 to the 3rd, that's 512. So we have 4/3 times 512 pi. Now I want to simplify this. Anytime I have a fraction in the problem, I want to get rid of that fraction as soon as I can. And the way I'm going to get rid of that is finding some value I can divide by 3. Obviously I can't divide 4 by 3 and get an even number. Maybe I can look at 512. If I divide 512 by 3, it actually does not come out. It's not evenly divisible. Now you can look at the shortcut of adding up the digits of 512 and seeing that it's not divisible by 3, but we can also kind of just use the idea of where did we get 512 from? 512 is 8 times 8 times 8. And what 2 is, or 8 is just 2 times 2 times 2. So really it's just a whole bunch of 2's. So instead of dividing that by 3, I'm going to multiply. I get 2048 over 3 pi inches squared. Now that is the exact answer. If we want to then divide 2048 by 3, we get it's about 682.7 pi inches squared, and you could even multiply by pi there and approximate. But remember, that is an approximation. Our most exact answer is where we left off here. Now we go to our next one. Volume here is 4/3 pi r cubed. This time our radius is still 9. It's not 18. Don't want to accidentally choose 18. 18 is a diameter. So if we do 9 to the third, we get 729. So 4/3 times 729 pi. Well, this time I can divide 729 by 3 because the way we got to that was 9 times 9 times 9, which has a 3 in it. And 729 divided by 3 is 243. So we get 4 times 243 pi. And 4 times 243 is 972 pi meters cubed. Oh, there's our mistake. We've got to go back to that first one and make it cubed. We want to make it squared. It is volume we are looking for. Okay, let's look at 2 more examples here. So we're going to find the surface area and volume of a sphere, and then we're going to deal with a hemisphere. So maybe you pause the video here, try the one on the left, see if you can figure out the surface area and volume, and then we can check your answer. So we're going to solve here. That's 4 pi r squared. Radius is 10, so 4 times 10 squared. We get 4 times 100 pi. Comes out to be 400 pi centimeters squared. Now we're going to look at volume. Our volume is 4/3 pi r cubed. Our radius again is 10. 4/3 pi times 10 to the third. That becomes 4/3 pi times 1,000. Now we can't divide 1,000 by 3 and get a whole number, but we could write 4,000 over 3 pi centimeters cubed. But maybe we want to simplify that a little bit and approximate, and that comes out to be about 1,333.3, that's repeating, pi centimeters cubed. Okay, now our last one here, surface area and volume of the hemisphere. I'm actually going to do volume first because this one's actually going to be easier. If we had a whole sphere and we looked at its volume, we would use 4/3 pi r cubed. But what if I just had half a sphere like I have here? So I'd actually take 1/2 of what I have right there. Now, half of 4/3 is actually 2/3 pi r cubed. So we could do that from the beginning, and then that'll help us solve it and get to our answer. Or you could again find the volume and then just take half in the end, but we want half the volume. So it's going to be 2/3 pi, radius is 5, so that's 5 to the third. We get 2/3 times 125 pi, and that comes out to be 250 over 3 pi inches cubed. If you went in and actually did the volume of the whole thing, I think you would have found that it was 500 over 3 pi, and hopefully you should see that's just by doubling the 250 over 3. But that's our volume of the hemisphere. Now, let's think surface area. So I'm still going to take that same idea and take half the surface area. That's going to be 1/2 of 4 pi r squared. But I have to add something to that. What I have to add to that is the disk, the circle that's on the bottom, because that circle is pi r squared, and that's the base of it. So we have the base, and it's almost like we have the dome. Because by cutting the surface area in half, we're just taking into account to the dome, but this actually has a base included. So it's going to be the combination of two things. So it's going to be 1/2 4 pi times 5 squared plus pi times 5 squared. We get 1/2 4 times 25 pi plus 25 pi. 4 times 25 is 100. Half of that is 50, so 50 pi plus 25 pi. We get an answer of 75 pi inches squared.